The Columbia River Gorge, a wonderful place for many things. Sure, it's windy out here and there's scenery, but there's also incredible geology. So many different kinds of things to look at that prompt so many questions. How long has the gorge been around? How did it form? Has the Columbia River always cut through the Cascades to the ocean? The rock layers in the walls of the Columbia Gorge. What kind of rock? Where did the rock come from? And why are the layers flat in some places and tilted in others? What does the tilting tell us about the history here? Where's the Bridge of the Gods? That sounds like a cool place. How about Celilo Falls? Why are there so many waterfalls in the deepest part of the gorge? What about Beacon Rock? Or the old Scenic Columbia River Highway? And I get this one a lot. The Ice Age floods that many people now know about coming from Montana, did those Ice Age floods create the Columbia River Gorge, blast a hole through the Cascade Range on the way to the Pacific Ocean? There's so much to study out here. Let's get busy, question by question, figure this stuff out. The Columbia River and its tributaries have drained a large section of North America for millions of years. Where the river cuts through the Cascade Range, that's the Columbia River Gorge, the state line between Washington and Oregon. How long has the gorge been here? How did it form? It's the only passage through the mighty Cascades. You might be scratching your head thinking of ways that the river could break through the mountains, but actually, the river is older than the mountains. The Cascade Range is not just a pile of lavas. Plate tectonic uplift formed the Cascades that we know today. 3,000 feet of uplift in the last 3 million years. Uplift during the Ice Age. But the Columbia River has had a much longer history in this region. Starting 17 million years ago, the Columbia River Basalts flooded the inland Pacific Northwest with hundreds of thick lava flows that came from deep cracks in the crust, up to 200 miles east of the Columbia River Gorge. Lavas that have nothing to do with the Cascade volcanoes. Back then, there was an ancient Columbia River Valley, 60 miles wide, kind of like today's Willamette Valley in western Oregon. And the Cascades in those days were low, a modest upland with occasional volcanic cones. The Columbia River Basalts used this early valley through the low Cascades to get all the way to the Pacific Ocean. We know this by carefully studying the lava bedrock in the walls of the gorge. Part of a wide swath of mostly Columbia River basalt layers found through this stretch of the Cascades. The thicknesses of individual lavas are remarkably constant from Idaho to the Oregon coast, which means they were flowing over a landscape that was pretty much flat. No major cascades at the time, no big gorge. But today, in the heart of the gorge, the Columbia River basalts are thousands of feet above the river. Why is this? What happened? Plate tectonic uplift. An uplift that created the modern Cascades. Remember, 3,000 feet of uplift in the last 3 million years. And the Columbia River, cutting against the uplift, made the gorge that we know today. The regional arching of the bedrock layers was so extreme that we have a rare glimpse at the rock layers below the basalts. Deep in the Cascades, the Eagle Creek Formation is exposed. Hundreds of feet of volcanic mudflows, lahars, pieces of petrified wood, and volcanic blocks from eruptions 20 to 30 million years ago. So the Columbia River Gorge that we know and love is geologically pretty young, cut in response to an Ice Age uplift episode. And that means the dramatic vegetation changes through the gorge created by a rain shadow effect is also a recent development. Have you driven through the gorge lately? There's a pretty amazing change, isn't there, from one end of the gorge to the other? It's certainly not all like desert stuff that we have in eastern Washington. You drive the gorge from west to east and you experience a change of 100 inches of precipitation down to 10 inches annually in 80 miles. A wet set of plants down to desert plants, with windsurfing and kite surfing in the transition between the two extremes, all created by tectonic uplift. The Columbia River itself had different courses in the broad valley it followed through the old low Cascades. There are very clear snapshots in time to confirm this. One of the Columbia River basalt lavas, the Priest Rapids flow, was liquid and hot when it came out of deep cracks in Idaho 15.2 million years ago. The flow developed great columns in eastern Washington where the land was completely flat back in the day. But as the lava approached the low Cascades, the lava found a river valley with an ancient Columbia River in it. Like filling a mold, the lava funneled into the valley and eventually hardened into basalt. At the Dalles, the Priest Rapids flow is mostly pillow lavas, as the lava battled water in the channel. Lava versus water is always dramatic, like in Hawaii today. Long after the lava hardened, the old valley walls weathered away, and the Priest Rapids basalt shows us precisely where the Columbia River flowed exactly 15.2 million years ago. And the best place to see this intra-canyon flow? Crown Point. The Vista House sits on top of 600 feet of a Priest Rapids lava flow that once upon a time flowed through an ancient Columbia River valley. Each lava has a unique set of minerals and isotopes, a chemical fingerprint used by geologists to follow the flows across the Northwest. Other lavas show different snapshots in time, where the Columbia used to flow, all within the broad valley long ago, with some of the larger lava flows making it all the way to the Pacific Ocean. So did the Ice Age floods make the Columbia River Gorge? The answer is no. Remember, the river was here before the modern Cascades, and the mountains uplifted against the river to make the gorge. But the Ice Age floods did leave their mark. The famous Ice Age floods impacted much of the Pacific Northwest over the last 2 million years. An ice dam in northern Idaho created glacial Lake Missoula. Repeated failures of the Purcell ice lobe meant 100 Missoula floods across eastern Washington. And one truly impressive flood from Utah, the Bonneville Flood, followed the Snake River in southern Idaho, cruised through Hell's Canyon, and entered the Columbia River at Pasco, Washington. A temporary backup, Lake Lewis, formed at Wallula Gap, the eastern gateway to the Columbia River Gorge. Every Ice Age flood passed through the Columbia River Gorge on its way to the ocean. The biggest floods through the gorge, an estimated 10 million cubic meters per second. That's 300 times greater than the largest historical flood on the Columbia River. The highest trim line at the Dalles is consistently at 960 feet elevation. And a bit downstream at Rowena Point, the floods really ripped into the bedrock. There's scablands here, like out in eastern Washington, classic features due to Ice Age floods erosion. The scablands at Horse Thief Butte are particularly impressive, giant potholes, and a basin and butte topography. And some of the largest floods overtopped a river-parallel ridge on the Oregon side. Giant flood bars were deposited, tons of rocks, dumped in quiet spots south of the river. Radiometric dates from material within the giant deposits means there's a long history of Ice Age flooding here. Not just floods since 18,000 years ago, which is the time frame usually presented to the general public. So did the Ice Age floods cruise through the gorge at maximum speed? And what's with all those tilted layers of bedrock? The tilted beds of the Columbia River Gorge are from plate tectonic forces applied to originally flat bedrock layers. But be careful, these tilted beds are not related to the Cascade uplift that we talked about earlier. Instead, the Yakima Fold and Thrust Belt, a family of folds and faults in central Washington, intersect the gorge. The crust of the Pacific Northwest has been slowly rotating clockwise for millions of years into a non-rotating northern Washington and Canada. The result? Anticlines and synclines, reverse and thrust faults, they all formed from crustal squeezing. Warps and cracks in the crust that formed after the Columbia River was established here. You want proof? The Columbia River makes an abrupt turn at Rowena and cuts right through the Columbia Hills anticline. You can't do that unless the river was here first and the ridges came second. In the middle of the Dalles syncline, a broad downfold, volcanic mudflows of the Dalles Formation are preserved. It's not all basalt around here. But here's a key point. The Yakima folds and faults have made narrow constrictions for the river to flow through. Wallula Gap was not the only choke point for the floods on their way to the Pacific. Many prominent valley constrictions exerted significant control on the Ice Age flood hydraulics. Wallula Gap, Rowena Gap, Bingen Gap, Crown Point. The water accelerated to 60 miles per hour at these bottlenecks, but just downstream from each constriction, giant flood bars composed of loose rocks that the floods dropped as the water spread and slowed. The whole town of Lisle, Washington sits on a flood bar downstream of Rowena Gap. The bar used to extend across the mouth of the Klickitat River. The Mosier flood bar sits where Ice Age floodwater diverted up a side valley. The town of Bingen sits on a huge flood bar downstream of Bingen Gap. And on an even larger scale, much of East Portland sits on a huge Ice Age flood bar downstream of Crown Point. Now, for all those questions about specific attractions in the gorge, iconic images of Native Americans harvesting and processing salmon at Celilo Falls, where can I find those falls, you say? Before they closed the gates on the Dalles Dam in 1956, Celilo Falls was a majestic place. When the river was low, Celilo had a sheer drop of 18 feet. In the reach downstream, narrow chutes were separated by large holes in the river bottom. Holes 130 feet deep, drilled by the Ice Age floods. That's 100 feet below sea level. The set of rapids, the Dalles of the Columbia, dropped the river 80 feet in 12 miles, and immense salmon runs fought their way up through the falls and chutes. Celilo Falls is no more, buried under still water behind the Dalles Dam. Downstream, where the river passes through the center of the Cascades, there's a very different reason that the river is choked down here. Lewis and Clark in 1805 took note of large stands of partially submerged tree stumps, a submerged forest of the Columbia, trees up to 25 feet tall, thousands of drowned stumps upriver as far as the Dalles. And Lewis and Clark were about to encounter a set of rocky rapids here, the Great Chute they called it, the Cascades of the Columbia. In this same spot, Native Americans spoke of a bridge of the gods, a legend of river crossing without getting feet wet, and not an ancient legend. Fathers voyaging upriver in their canoes without obstruction as far as the Dalles of the Columbia. What happened here? An enormous landslide, the Bonneville landslide. Part of the Washington side of the gorge slid down and buried the Columbia River channel with 300 feet of loose rock. The slide pushed the river a mile south towards Oregon, making a landslide dam 3 times higher than today's Bonneville Dam. And above the slide, impressive cliffs, the headscarp of the slide where the mountains split. Upstream of the slide, the river rose 40 feet. The Lake of the Gods extended tens of miles upstream. Today's Skamania Lodge would have been lakeshore property. The lake eventually overtopped the rock blockage and drained. After cutting a passage through the slide down to its current bed, the rapids first made their appearance. Lewis and Clark's Great Chute Rapids? Boulders from the toe of the Bonneville landslide, rocks too big for the river to flush through the gorge. Later in the 1800s, locks were built to negotiate the rapids, the landslide blocks. Today, the rapids, as well as most of the Cascades locks and canal, are underwater, drowned in 1938 by the reservoir behind Bonneville Dam. So what's the age of the Bonneville slide? It was before Lewis and Clark, right? Before 1805? Maybe the slide was triggered by the great magnitude 9 earthquake that struck all the Pacific Northwest on January 26, 1700. Tree rings were counted in cores from 50 living trees growing on top of the landslide. The result? Nope, not from the 1700 quake. These trees are as old as the mid-1500s. And radiocarbon dating from the submerged trees gives us mid-1400s as a confirmed date. So the Bonneville landslide, the Bridge of the Gods, they blocked the Columbia River around the year 1450 AD, more than 2 centuries before the Great Earthquake and more than 3 centuries before Lewis and Clark. So what triggered the Bonneville landslide and so many other prehistoric landslides on the Washington side of the gorge? The bedrock is the answer. 700 feet of Columbia River basalts overlie 900 feet of Eagle Creek Formation, layers of volcaniclastics and mudflows. All of those layers tilt south toward the river, a well-greased skidboard where rainwater penetrates the cracked basalts and concentrates at a clay layer. Landslides in the Columbia River Gorge are part of the past and our future. The layers still dip, the clay is still there, and it still dumps rain in the heart of the gorge. Continuing downstream, another familiar landmark, Beacon Rock. Hey, is this one of those inter-canyon flows? No. Beacon Rock is an 850-foot-high remnant of an eroded volcanic neck that's only 57,000 years old. Think today's Lava Butte in central Oregon, a volcano that formed in the middle of the river. Lava would dam the river on occasion, but the volcano was no match for the river. And back in the early 1900s, Henry Biddle built steps to the top. Walk your family up the center of a volcano. The glorious waterfalls in the gorge, Multnomah Falls and others. Why are there so many here? They are primarily the result of Ice Age cutting by the Columbia River against the uplifting Cascade Range. The gorge cutting prompted landslides from the Washington side to push the river to the south side of the gorge, which repeatedly undercut thick, stubborn, older Columbia River basalts. The Ice Age flood swept through the gorge on occasion to clean up the walls, but the waterfalls are really a direct result of tectonic uplift. After all of this geologic history, and after Lewis and Clark, European-based settlers began arriving. The Oregon Trail approached the gorge from the east, and the old Moody Road was a primary route along the southern edge of the Columbia River. The heart of the gorge lay ahead, a giant obstacle. How to proceed? The wagon trains decided, well, are we going to get wet by following the river? Or are we going to stay dry by climbing up and over the Cascades near Mount Hood? The Dalles up ahead became a major stop for the Oregon Trail travelers to ponder that question. Decades after the Oregon Trail, early steamboats cruised up and down the river. And then in 1915, the first successful highway to cross through the Cascade Range, the Columbia River Highway, was constructed to harmonize with the beauty of the gorge. Graceful sets of curves, separated by viaducts, bridges, tunnels, all faced with natural stone, worked by European masons. A brand new Vista House presided over an amazing landscape suddenly accessible by automobile. With the grand opening of the highway in 1915, a young geologist, J. Harlan Bretz, was hired to write a roadside geology guidebook. His first taste of deposits and landforms that got him thinking for the first time about huge floods of water from a then unknown source. A controversial topic that initially brought him scorn and ridicule, but eventually brought him fame and acceptance worldwide. Of course, the wild Columbia River was tamed in the 20th century to harness the power of the river. A continuous string of reservoirs, ending at tidewater at the foot of Bonneville Dam. Today, the Columbia River Gorge National Scenic Area, with the Discovery Center in its hub, is famous for its hundreds of hiking trails and gorgeous wildflowers. The National Scenic Area designation allows for preserving the scenic quality by regulating land use and development and through property acquisition. All of this geology has forced barges, salmon, railroads, and highways through this narrow slot through the Cascades. Geologist Jim O'Connor has devoted many years to advancing our understanding of the geology of the Columbia River Gorge, and his work is not done. By dating various young lavas that came into the gorge at various elevations, like the pillows in the freeway road cut just west of Hood River, we can improve our grasp of the timing of the Cascades uplift and the river's downcutting. More work is also needed on the history of river blockages here. So many lava dams and landslide dams through the history of the gorge. How did those blockages affect ancient fish populations? Stay tuned. Like all branches of the sciences, there are always new questions that geologists will work to answer. An awe-inspiring place, the Columbia River Gorge, a beautiful geologic laboratory for all to enjoy.